Hello, today we're going to be looking at IGCSE Computer Science, the programming part of May-June 2024, Paper 2, Component 2. So here we have the question. It says a one-player game uses the two-dimensional 2D array grid. So let's highlight this for emphasis sake. To store the location of a secret cell to be found by the player in 10 moves. Each row and column has 5 cells. So you have 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. Okay. The program places an X in a random cell, not in grid 1, 1. So not in the first grid, and empties all other cells in the grid. So every other cell becomes empty apart from a random cell that will be picked to have X. Now, the player starts at the top left of the grid, which is this very start point. The player has 10 moves. Okay, so the idea is that you randomly pick a location. Let's say here, and then the player starts from here. This location of X can be anywhere at the start of the program, anywhere but here. Okay, so the player has 10 moves. Now the player can move left, right, up or down. So the player can move left, can move right, can move down, can move up. However, there are restrictions, okay? And the move must be within the grid. So if the player is here, the player cannot move up. If the player is here, the player cannot move left. Okay. Your win is displayed if the player moves to the cell with X. So the player continues to move as long as he's within 10 moves. Okay. Until he meets this very point here and has played 10 moves or less. You lose is displayed if the player has 10 moves without finding the X. Okay, let me explain quickly. Now this program looks like the guess number kind of program, where the computer is going to have a randomly generated number, and then the user keeps guessing until the user gets the right number. Okay, so but this one, you are moving on the grid. You are not just guessing a number, you are making your moves on the grid. Okay, so let's go straight to writing the program. All right, so as usual, I'm going to copy this, which is the instruction, and then I'll put it into my Python, and then I'll use it to write the program and use it as part of my comment as well. Okay, so the next thing is, what do we need? We need an array. We need a 2D array called grid. Okay, so now remember, it is important to spell it the way it was spelled. Very important. All right, so this should be a 2D array, and by default we are supposed to empty out all the cells. Remember, the instruction said the program places X in a random cell as long as it is not cell 1, 1, which is the first cell, and then it empties all other cells. So we need to create a grid, populate that very grid with empty cells. Okay, so a quick way to achieve this in Python is simply to write this code: empty. Now remember that the instruction says, from the image that we saw, it has 5 columns and 5 rows. Okay, so the columns needs to be 5, and then the rows need to be 5 as well. Okay, so since we have done this, we are good to go at this point. Let me quickly show you what this grid will look like. Okay, so this is what it's going to look like. This is the first row, second row, third row, all the way to the 5th row. Yeah, now there is something I want to do here. I want us to visualize this to look exactly like the table that, like the grid that they have drawn here for us. So this part that I'm going to add is completely unnecessary for the examination. Okay, so in case you are trying to attempt this question, this very part is completely unnecessary, but I'm just going to do it for understanding's sake, so that it will be easy for us to have a mental picture, okay, to visualize what the game looks like. To enable me do that, I am going to import a library. I have already installed it before now, so in case you don't know how to install, please find a way to install it depending on the IDE that you're making use of. So I am going to import the terminal tables. So from there I need ASCII table. So this very library is going to help us visualize what the table is like. Okay, instead of printing, I'm going to take this out, and then I will do grid equals, and then I'm going to print the grid. Okay, so let us run this program to visualize what the grid is going to look like. Okay, so this is the idea that I want us to have, so that each move that we make, each time we move the player, we can visualize how the player is moving, and then we can equally visualize how where the X is placed. However, this part, like I mentioned, is completely unnecessary as per the requirements of the question paper. The program places an X in a random cell. Okay, so we need to import the random library here, okay, in order for us to generate two random numbers. Let me point out this place. Since we're using Python, let us remember that Python starts its range for arrays from 0. Okay, so that means, so let's say S row, okay, and then we also need S column. Now this one is the position of the X. Remember the X, this X, this X. Okay, so let us randomly generate two numbers that would determine where the X will be placed. So let's start from 0, 0. Remember, we're not supposed to put anything there. Okay, okay, so the idea is that as long as X remains 0, the S row remains 0, and the S column remains 0, it will keep generating random numbers until it meets this very condition. Okay, because we need to avoid placing X in the first cell there. Okay, so the next part says the player starts at the top left of the grid. Let's give them 0, 0, which is where they are supposed to be. Okay, so we are placing this in order for us to visualize the two of them, okay, where they are. Now, so I haven't done this, we now need to place X. Print this again, we will practically see the new state of the grid. You see? So X has been placed there and P has been placed there. Now let's run this again to see if the position of the S is going to randomly change. You see? Changed, but P remains in the same location. So the player has 10 moves. Let's say the max moves is equal to 10. So the player cannot move more than 10 times. Okay. We need to also check if the player has won. Okay, so let's say win equals 4. So at this stage, the player has not won yet. Okay, so this part says that during the game, the player can move left, right, up, down, by one cell, and the move must be within the grid. So what do we need to do here? We need to check, as long as you have not exceeded the number of moves, as long as the mass moves is greater than 0, that means you've not exceeded your number of moves, and as long as you have not won the game. Okay, so you need to keep moving. Yeah, so move will be equal to, let's take the input. So we need to know where the user intends to move. So the user needs to choose left, right, up, or down. Okay, so we can just drop a comment here. But then we need to check to make sure that the player has not left the grid. Okay, because here move must be within the grid. So we need to check this. Very important. Okay, so how do we check that? Let's use match. So in case the user moves to the left, we need to check. What do we need to check? If I move to the left from here, remember I am still on the same row, but I have changed column. Remember that in Python, this is 0, 0, row 0, column 0. Alright, so if I move leftwards, my row remains the same 0, but my column has moved -1. Okay, so we need to make sure that the column has not reduced to -1, and we need to make sure that the column does not exceed 5, right? So in our case, it's going to be 5. Yeah, making sure that it does not exceed 5, making sure that it does not go beyond 0. The same thing with the row. But remember, we have P column here because we need to check if you have moved outside. Remember that the row remains the same, but the column changed. Yeah, so we're looking at for the change in the column. So we're checking for the error move there. So we need to let the user know that he or she cannot move outside of the grid. Because of the position of the player, the left move will not be allowed at that point. Yeah. Okay, so here, so if the player did not go outside of the grid, what next do we need to do? We need to accept that the user has made one move. So how do we do that? By reducing or decrementing the mass move by 1. So having reduced the mass move by 1, we need to inform the user, very important, how many moves the user has left. Although it was not a requirement from the question, but to make it more interactive, it is important that we do that. Once the player makes a move, we now need to check if that move is the winner move. So we need to check if that is the position of X. So remember here, the move reduced the column by 1. Yeah. So we now need to check if X is in that position. And we also need to check if the user has not done the maximum number of moves as well. So if that is the case, we now need to print that the player has won. So I can just copy this. Sorry. So once we have confirmed that the player has won, we need to turn the win to true. And once that is the case, we need to break away from this loop. There is no point for the user to keep entering. Okay, remember, this will keep happening until this condition is met. Yeah, so we break away from the loop. So let's say ends the loop. If the user has not won, so we need to move this P to the new location that the player has chosen. So let's say empty cell updates the column data. So this one moves the player. So in order for us to see what is really happening there, we can just choose to print our grid. Okay, so we can just say current state or current grid, as the case may be. So let's print this and see what happens. Let's run this, sorry. Okay, so this is where we are. So let's say I choose to move left. The program should automatically identify that I'm making the wrong move. You see, you made the wrong move. So I can only move up or down, you know, as the case may be. All right, so let me try to move right and see what happens. Looks like this is working okay, because we've not actually programmed what will happen if we move right. So let's try to do that. Let me just copy all of this so that the program will be a lot easier for us. Copy all of this, and then I'm going to change it into the new case. Give a space, and then I'll paste this here. But remember, this one is for the right move. Okay, so if we move right, we are increasing the column, but the row remains the same. So here should be the row for the player, and then we're doing +1. Remember, so what do we need to check? By the time the player gets here, the player cannot go beyond this point. Okay, so this should be 5. 1 2 3 4 5. Remember that? Yeah. Okay, so we're checking for error moves. Got it? Okay, so in case you're wondering why 5, remember, this is 0 1 2 3 4. So maximum 4. So once it goes beyond 4, then that is an error move. Okay, so we now need to change this. So right is the wrong move. You can't move outside of the grid. So what next do we need to do? Okay, so this is still the same. We need to reduce the max move by 1, and then we need to also print the maximum number of moves, and then we need to check if the user has won. But in checking if the user has won, remember that the column increased. Okay, this one can still be the same. So print you win, then win true, and then you break. However, after doing that, let us update the position, assuming the user did not win. Okay, so whether the user wins or not, we need to update. Okay, so because if the user wins, that means we will break. We don't need to do this. But if it doesn't happen, let us update. So what do we need to update? We need to remove P, which is the position of the player. Okay, and then update the column by adding 1 to it. Remember, the user moved right, which is increment of the column, and then change the position of the player. Then we can now display the current state and let the user know exactly what is happening. So you know, we checked already for left. It tells us we can't move left. That's the wrong move. So let's move right and see what happens. Good. So this is the state. Okay, so when we move right, we have 9 moves left, and this is the current grid. You see the P moved to this point, the player moved, but the X remained the same. You see it, player moved, but the X remained the same. So that's how we'll keep changing it until we have 0 moves left. Okay, so let me stop running this. So since we've done right and left, we now need to do up and down. So let's do up first. So I will still copy this. And then I'm going to paste it. Okay. So what do we need to change? We need to change up because we're moving up now. Okay. Now in this case, when you move up, you are changing the row. You're not changing the column. All right. So we need to check if the row movement by -1 is a wrong move. Okay, so you say up is a wrong move. Of course, we need to reduce the max move by 1, very important. And then we need to print the moves left. Then we need to check if the player has won. So how do we check that? We are not reducing the column this time. Remember that we are reducing the row. So if the user has won, we'll say you have won, and then we need to update the win, and then we need to break away. All right, so what else do we need to change? Remember, we're dealing with the row this time around, not the column. Yeah, you remember? Okay, right, dealing with the row and not the column. And then this remains the same. We change the position of P, then we still have to print this. All right, let's try it again and see how it works. Sorry, I keep trying and checking. Let's be sure. So this is the state. So let's move up. Because this is located here, it is not going to let us move up. Okay, let's check you. No, you can't go up. You'll be going outside of the grid. Get it? Okay, so finally let us do down. When you go down, you are changing the row. Okay, so let's pick this one because it closely aligns with what we're trying to achieve. So this case, give a space and then I'll paste it there. Okay, so this is down, which is D. If you move down, you're changing the row. Yeah, you're changing the row by adding. Okay, 1. So and then you print down. If the user goes outside, you print down is a wrong move, and then mass move equals this. Okay, you update this number of moves left. You win is displayed. Okay, so here remember we're not dealing with the column, we're dealing with the row. So you add 1 to the row, and then the user gets to win. If the user is in the right location, we update win to true, and then we break up. Then we come back here. Remember, we're not dealing with the column, we're dealing with the row. So we change this to row, change this to row. Okay, after that, I think this one's largely remain the same, because we still have to update the position and then print out the state, the new state of the grid. Okay, so let's try this and see what happens. Let us run again. Sorry, I keep running each time. Let's be sure that everything is working well. So that is the state of the grid now. So let's move down and see what happens. D, you see? So I have 9 moves left. Let me move down again. You see, it moved. 8 moves left. Let me move to the right. Okay, I'm almost there. Now let me move down and see if it's going to recognize that I have won. 6 moves left. You win. Woo! What happens if I exhaust my move? Okay, so we need to program that part. Now, you lose is displayed if the player has made 10 moves without finding X. Okay, so that means we need to check if the max move it's equal to 0, yeah, or not win if the user did not win. Okay, and then we need to print you lose. Let me add an exclamation mark to it. I don't think that will be a problem. Okay, so let's run it finally to see what will happen. So let's deliberately make 10 wrong moves to see if our program is going to work accordingly. So let me move down, move down, move down, move down, move right. Okay, let me move down here to see if the program is going to tell me I'm making the wrong move. Good, good. So let me move right. Hold on. Looks like we have a problem here. I can move right here. So why do I get I'm making the wrong move? So let's go to right and see what happens. Right. Also, here is a problem. When I move right, I'm not changing the row. I'm changing the column. Sorry about that. Any other mistakes here? Okay, so we updated this, but we didn't update that. So that's the only problem. Okay, so let's try it again. Let's see what happens. Sorry about that. So let's say you're there. Good. So let me just keep moving. Down, 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 down. Let me try down again. Wrong move. Let me do right. Good. Right. Good. How many moves do I have left? Right. I want to make sure I exhaust the number of moves that I have. Let me move up. Let me move up. Let me move up. How many moves more? Okay, one move left. Up. Aha. So I've moved up, but nothing happened. So I've exhausted the number of moves. So at least it's not asking me to continue entering. So I believe if we take out this not win, that should solve the problem. Okay. Let's try it again to see what happens. Good. So this worked correctly. All right. So you see it has displayed you lose. Okay. So this marks the end of the program. Thank you all for your time. Please do well to share, do well to like, do well to subscribe. Okay. So that when next I post any video, you will be the first to know. Thank you for your time. I hope this video was very interactive, and I hope it wasn't too long because of all of the extra things I had to add to it. Thank you, and see you again in the next video.